Because what you're about to see does not fit comfortably inside the version of Mars we were taught to accept. Mars, a dying world, a frozen desert beneath a fading sky, a planet that lost its air, its warmth, its water, and with them, its chance at complexity. That is the narrative. But narratives are simplified. Planets are not. Look closer at the terrain captured by orbiters circling Mars. Look beyond the red dust, beyond the impact craters, beyond the easy conclusion of barren. Some regions are not chaotic. They are layered, structured, deliberate in appearance. Terraces descend into craters like ancient shorelines. Ridges align in repeating patterns. Polygonal fractures stretch across plains in geometric networks. Mars should be ruled by randomness, by 4 billion years of impacts and erosion. And yet, in certain places, disorder gives way to pattern. Is it illusion? Is it the human brain searching for symmetry where none exists? Or are we looking at the preserved fingerprints of processes far more complex than we once imagined? Because if this is natural, then nature on Mars operated with precision, with timing, with environmental balance sustained over immense spans of time. And if that balance existed, even briefly, then Mars was not always the world we see today. Pause. Look again. This is not a story about shapes and rocks. It is a story about planetary transformation, and it begins billions of years ago. If questions like these pull you deeper into the unknown, subscribe to All About Mars Surface. Share this video with someone who refuses to accept easy answers. And tell me in the comments, what do you see? Let's explore the red planet together. There was a time when Mars was warmer. Not tropical, not Earth-like in every way, but warmer. Its atmosphere was thicker, denser with carbon dioxide, heavy enough to support stable liquid water at the surface. Evidence comes from valley networks stretching thousands of kilometers, branching like river systems on Earth. Delta formations lie preserved inside ancient craters. Sediments are layered with unmistakable order. NASA's Mars Perseverance Rover Discovery Reconnaissance Orbiter has mapped these features in extraordinary detail. The images reveal channels carved by persistent flow, not a single flood, but sustained runoff. Water moved here, repeatedly. Crater rims were breached by incoming rivers. Basins filled. Shorelines formed and receded. In Jezero Crater, now explored by Perseverance, a fossilized delta stands frozen in time. Layered sediments fan outward exactly as they do in terrestrial lakes. Deltas require stability. They require standing bodies of water. They require time. Mars once had all three, but stability on a small planet is fragile. Unlike Earth, Mars lost its global magnetic field early in its history. Without that protective shield, solar wind, a continuous stream of charged particles from the sun, began stripping away the upper atmosphere. Welcome to All About Mars Surface. In this episode, we descend further than ever before, beyond the visible terrain, beyond the dust, beyond the illusion of stillness, into the hidden architecture that shaped Mars from the inside out. Today, we are not just examining the surface. We are investigating the memory beneath it. From orbit, Mars appears desolate. Endless plains of oxidized iron stretch toward a silent horizon. Impact craters dominate the landscape like scars from a violent past. Volcanoes stand frozen in time. But orbit can deceive, because beneath that thin, fractured crust lies a planet that once circulated water through stone, that once stored heat beneath insulating layers, that once sustained chemical systems far more dynamic than the red dust suggests. Subsurface ice is not a minor discovery. It is a revelation. Using advanced radar instruments aboard the Mars Reconnaissance Orbiter, scientists transmit radio waves deep into the Martian ground. When those signals reflect back, they carry encoded information about density, composition, and structure. Solid basalt reflects differently than porous sediment. Ice reflects differently than rock. And what those reflections revealed changed everything. Vast deposits of buried ice stretch across the mid-latitudes, not only at the poles, but in regions once considered too warm to preserve it. In certain locations, that ice rests only meters beneath the surface, shielded by a thin, insulating blanket of regolith. This dusty layer slows sublimation and protects frozen reservoirs that have endured for millions of years. In steep scarps, erosion has sliced downward, exposing bright, nearly pure water ice. Layered, stacked, preserved. These are not random pockets. They are climate archives, formed during earlier epochs when Mars tilted at dramatically different angles. NASA's MAVEN measured this escape directly. Atoms still leak into space today. Over millions of years, pressure dropped. Temperatures followed. Liquid water became unstable at the surface. Lakes evaporated. Rivers thinned. Ice advanced. Water did not disappear. It migrated. Some of it froze into polar caps. Some of it locked itself into minerals. Some of it retreated underground. Mars was not abruptly silenced. It faded. Today, the polar regions hold vast reserves of frozen carbon dioxide and water ice. Layer upon layer, stacked like pages in a climate archive. Each band records a shift in dust levels, a fluctuation in tilt, a change in atmospheric density. Mars does not hold its axis steady. Over millions of years, its tilt swings dramatically, far more than Earth's. When the tilt increases, sunlight reaches the poles more directly. Ice sublimates. Moisture migrates toward mid-latitudes. When the tilt decreases, the poles grow colder. Ice accumulates again. The planet breathes, slowly. Even now, thin clouds drift across the sky. Dust devils twist upward and vanish within minutes. Global dust storms occasionally engulf the entire planet, as witnessed by Opportunity before its mission ended in silence beneath a darkened sky. Mars is quiet, but it is not inert. Beneath the surface lies another chapter. Radar instruments aboard orbiters send pulses into the ground and measure the echoes. In many mid-latitude regions, the signals reveal something unmistakable: buried ice. In some locations, only a thin blanket of soil separates the surface from nearly pure water ice below. Cliffs expose bright layers where erosion has sliced downward, revealing frozen reservoirs that have endured for millions of years. These deposits are not random frost. They are remnants of past climate cycles, relics of migration when ice once shifted across the planet in response to orbital change. Further evidence comes from mineralogy. Clay minerals form in the presence of long-term water interaction under neutral conditions. Sulfates form in more acidic, evaporative environments. Across Mars, clays dominate the oldest terrains. Sulfates appear in younger regions. This sequence tells a story: a transition from wetter, stable conditions to drying, chemically harsh environments. Hydrated silica deposits hint at hydrothermal systems, water heated by volcanic energy circulating through fractured crust. On Earth, such systems teem with microbial life independent of sunlight. Mars once possessed the heat, the water, the chemistry. The question remains whether it possessed biology. Massive volcanoes dominate parts of the Martian surface. The largest, Olympus Mons, towers nearly 3 times higher than Mount Everest. Volcanic heat interacting with subsurface ice could have created temporary lakes beneath insulating layers of rock. When those lakes refroze or drained, the ground above may have collapsed, forming chaotic terrains visible from orbit. Gigantic outflow channels cut across the planet, carved not by steady rivers, but by catastrophic floods. Pressurized groundwater reservoirs may have burst through weakened crust, releasing torrents capable of reshaping entire regions in days. Mars was not always slow and frozen. It experienced violence, energy, sudden release. Today, dark streaks appear seasonally along steep slopes. They fade and return. Their origin remains debated. Some scientists propose dry granular flows triggered by temperature changes. Others once suggested transient briny water might play a role. Regardless of mechanism, the phenomenon demonstrates. Wind redistributes dust across continents. The planet breathes in cycles measured not in hours, but in seasons and epochs. Why does this matter? Because Mars is more than a destination. It is a case study in planetary evolution. Earth and Mars began with similarities: rocky composition, volcanic activity, surface water. Yet one remained habitable, the other did not. Understanding why is essential, not only for planetary science, but for understanding the fragility of atmospheres everywhere. Subsurface ice on Mars may one day sustain human explorers, providing water, oxygen, and fuel. Buried environments offer protection from radiation, a necessity on a planet lacking magnetic shielding. Future missions aim to drill deeper, to sample beneath oxidized surfaces, to search for preserved biosignatures shielded from harsh radiation. The next generation of explorers may uncover organic molecules locked within ancient sediments, or they may confirm that Mars was habitable, but never inhabited. Both answers reshape our understanding of life's rarity. Mars is not defined by what it lacks. It is defined by what it preserves. Ancient shorelines, mineral transitions, buried glaciers, volcanic scars. Each is a chapter in a planetary biography written across billions of years. From orbit, it looks silent. From a distance, it seems simple. But beneath its dust lies memory. Mars is not merely a red wasteland. It is a record of change, of atmosphere lost, water displaced, climate transformed. And perhaps, somewhere beneath its frozen crust, secrets still endure, waiting for the next drill, the next rover, the next careful observer to uncover them. This is not the end of the story. It is an unfolding investigation. All About Mars' Surface will continue tracing these buried systems, exploring how time reshapes worlds and how even a quiet planet can hold a history far more dynamic than its surface suggests. Look carefully, question assumptions, study the layers, because Mars is not just a surface, it is depth, and in that depth, its greatest mysteries remain. Subscribe to All About Mars' Surface. Share this exploration with someone who refuses easy answers. And tell me in the comments, when you look at Mars, what do you see?